My name is Scott Sosna. This is my presentation, Everything But the Kitchen Sink Digital Jukebox. Few questions. Who listens to music? Who listens to music at work? Who listens to music at work out of desperation because everybody's talking about last night's football match and you've got a build break to fix? Yeah. Okay, so this is a project I did on the side, but it actually ties into some of the things I've done work-wise in the past, but not to this level. And I call it Everything But the Kitchen Sink Digital Jukebox because literally I gathered a bunch of disparate technologies to try and put something together more complicated than it should be. And if the kitchen sink was IoT enabled, I'd probably include that as well, but it's not. So we kind of went through introductions. My name is Scott Sosna. We're going to talk about my life in audio. We're going to talk about a streaming radio station that I used to run personally called RadioNonsense.com. The bulk of this is going to be about the digital jukebox and all the stuff you see up here that somehow made the trip from the US and somehow works today. I don't know how, but I'm happy. We'll do a little bit of a demo, we'll do a Q&A, and at the end of this presentation, I've got a lot of links if you are interested in anything. If questions come up, let's ask them, but if we get too nuts on the questions, I'll have to defer to the end because I don't think I'm going to get through everything, but we'll try. So who am I? Scott Sosna, and I'm an architect. I work at Dell Technologies in Minnesota. I've been there since 2011. For those geographically wary of what Minnesota is, northwest of Chicago, it's a state that goes all the way up to the Canada border. Very cold and snowy winters, very lovely springs, very hot summers. If you're ever there, pick May, September, avoid January and February. I've been in this industry for a long, long time. I've worked in business shops, I've worked in software shops, in all sorts of different industries, individual contributor, technical leadership roles, and I've taken projects from conception to implementation to actual retirement. And then, of course, because we don't get enough work, enough technology at work, we pick up things to do at home. This is one of them. So many sideline projects at home over the years. And I am a music lover. I ran my own web station for 10 plus years. I've got thousands of CDs because I thought that I would be able to retire off of them, not realizing that they're going to be absolutely worthless. But I've got lots of music, and there's some contact info, and I've got more at the end, so we'll put that up later if you want to take a picture of it. So you're going to indulge me briefly. We're going to talk about my history in audio, kind of where I started and where I got to. And the first thing I ever had, Fisher-Price kids record player. It's kind of like a music, some of those music boxes with the little pins. The records will play Camptown Races or Twinkle Twinkle Little Star. Great for a kid, can destroy it and make music. That was literally my first one. My first real piece of music, my dad gave me a 45 of Wild Thing by the Trogs. My first one. I don't have it anymore. My dad's a hoarder. I bet when we clear out his place, we'll find it. But that was my first piece of music. So obviously, if I've got records, I've had record players. Any number of them. Ones from ones that kids can play with and not hurt themselves to ones that would drop the records down as they finished one album and started the next. I've been in radio as well, so I've had many different ones like this. Many different radios. This is a portable radio, mono, if you can imagine that, AM, FM, shortwave. I used to listen to a radio station in Chicago, WLS 8900. Used to be the top music station in the upper Midwest. Now they're like news and sports and politics and crap like that. My first portable cassette deck, which I got because the girl in the class ahead of me, which I was enamored with, had a blue one. I got a red one. But great because you go on trips for school or whatever and you can play all the music you want. And then, of course, the Walkman, probably the first personal musical device. I had lots of cassettes. What better thing to do than carry around a bunch of cassettes and play them? Everybody had a boombox, I think, back in the day. Even better for loud bus trips with lots of kids. Reel-to-reel tape recorders. My dad got one of these for graduating from law school. He proceeded to put all of his albums, recorded them onto reel-to-reel tapes, and then gave me and my sister some of his records, including an original Meet the Beatles, which got trashed. But I use those in radio as well. Higher quality than cassette decks. You don't see many of them anymore, obviously, but you still can buy them, and I actually bought one for my dad recently so he could play all his old reel-to-reels. And then I had and I still have, this Onkyo amp. The amp is so old that the label for the CD, when you select what you want to play, said CD/aux, because really nobody knew what a CD was at the time. So I got that back in the 80s, Infinity speakers, still have both of them. Let's talk digital. My first CD player. Again, personal music, cheap. If you shook it too much, you wouldn't hear anything. My first album, Sgt. Pepper's. Come on, keep going. Pre-iPod. This is an Art Show Jukebox, 10 gig spinning drive. It looks like it's designed really cool with the borders. That's where you put the AA batteries. Terrible life, terrible GUI, didn't last long, became a portable drive that I would plug in at work. But my wife got it for me, my first one. And then, of course, everybody had iPods back in the day. Mine is a 160 gig, could almost fit my entire musical collection. It's sitting at work spinning randomly songs because I just want to pick up my headphones at work and hear it. Then I wanted to stream through the house. And I first started with an Airport Express. You take the iTunes, it streams to this. There's a speaker plug there. You plug in your amp there, and you can play music through the house. Not great, not very maintainable, not usable by anybody but me, which doesn't help my wife if she wants to hear music. So then I moved on to something called a Sonos. If you haven't heard of Sonos, wonderful toys. You hook it up, you point it at a drive in your local network, and it'll display all your music. It'll play online radio stations, things like that. So lots of different technologies. I've probably seen everything and used everything to the point where I've bought multiple copies of the same album on different media, right? Cassette and record and CDs. No 8-tracks, no digital cassettes. And I was a radio disc jockey at 3 different radio stations. KRUI is a college radio station, KFAI is a community radio station in the Twin Cities, and Mix 96.5 is a commercial station. Was I any good at it? Yeah, probably not, but I had fun. So first let's talk about RadioNonsense.com. And it was my streaming audio station. And the reason it came about is, first off, I was sick of picking which CDs I should bring into work every day. Because I've got a lot of CDs and I want to play them all. But some of them just aren't good for software development. Some of them, you can't listen to the whole album and get anything done. And there's an American Folkways album, and it's all sorts of up in the mountains, 30s folk hillbilly music, and I can listen to a song or two, but I can't listen to the whole thing. It just drives me nuts. So at the time, I worked for NetRadio.com, and they were one of the first online radio sites. They don't exist anymore. They were about the same time as Spinner.com and Mark Cuban. Spinner did their IPO. They succeeded. NetRadio did their IPO and fell flat on their face. But it showed me how easy it really was to do it. And so I said, well, if they can do it, and I was working for them and I learned all the tricks, I can do it. And I literally ran it for 10 years out of my basement, out of a rack of servers. And I had listeners all over the world. I had British troops in Afghanistan, up and down the Rhine, across the US. Basically, I take the IP address, reverse out, look it up, GeoIP, look it up, and it would show me where they were. One address actually came in as North Korea. I don't believe it, but it's a nice thought, right? So here's the technology, more traditional technology that I had for RadioNonsense.com. The left is my network, my home network. These are all individual servers. I literally have a rack in my basement that was populated with crappy servers that I was running this on. I had a Postgres database that has a complete copy of all my albums, songs, artists, labels. All of that information will capture what songs, will store what songs have actually been played. I've got a JBoss server running a web app with EJB2. So this is really J2EE, right? If you ever say J2EE now, people are like, no, it's JEE. That was J2EE. That's how old it was. And the web app would do things like update the database, query from the database, give me some random songs that I could potentially play, things like that. The player would make calls to the JBoss app, say, give me a bunch of songs that potentially I could play. It would randomly pick one of the songs or pick some of the songs, queue them up, and then it would stream the songs. The files were all sitting on another NAS server somewhere. The audio output from the player went to the input of a streamer machine that was running a Shoutcast server. Shoutcast was, at the time, a free streaming device, and so I could broadcast hooked up to the Shoutcast server, and in fact, I would stream that to a live stream provider, which I paid for, and through the internet, any number of listeners could listen. And it was kind of fun. And it was great for me because I would just hear random songs throughout the day, would have no idea what I was going to hear. I could control it if I wanted to. And, over the course of 10 years, had thousands of listeners. Actually found myself Googled once, and somebody actually said, yeah, this is a cool site. But I stopped paying for it, and it went away. So that got me thinking about a digital jukebox. How would I resurrect this currently, using current technologies or using unrealistic technologies? So we'll talk about a bunch of stuff that composes the jukebox. Now, I talked about RadioNonsense being a rack in my basement. This is my current rack. So this little Lego thing, 4 Pis, that is doing all of the functionality that I'm going to talk about here. So again, back in the day where there wasn't virtualization, I didn't have VMware running in my house. I had 4 servers, 200, 300 megahertz servers with 2 gig of memory, and an incredible electrical bill. Now I'm doing it here. So much different. But let's talk about the infrastructure. Bunch of Raspberry Pis, right? Came from Britain, so how much more appropriate would that be to rely on them here? I'm using Raspberry Pi Model 3s. Here are the specs on them. Most people are aware of them. In this case, the operating system, I'm using Raspbian, which is a Debian offshoot, specifically for the Pi. And I've installed the Lite with no desktop version. I didn't want to waste any CPU time doing a desktop that I'm never going to connect to. And in fact, these just boot up and everything starts by itself. The only time I need to connect to it is if I'm actually reinstalling the operating system. So I put Lite on there because that's really all I needed. I have a router. I made this network totally contained within this for the most part because I didn't want to rely on, for example, the Devox network, not knowing what it would be, not being sure how it would be set up. And in fact, I came yesterday to try and test it all out to find that my addresses that I had in my router overlapped the addresses of the Devox public network, so I had to renumber everything yesterday. So wanted to make it as self-contained as possible. And for the most part, it is. You need something with good power on it. Raspberry Pis like 2.5 amps of power compared to the 700 milliamps that the original Raspberry Pis required. This is not going to come out of your cell phone charger. It's not going to come out of your laptop. It's not going to come out of the wall plugs. You need something. And I've got, in the middle here, this Anchor PowerPort 6, which I think can handle about 50 amps. It's a pretty powerful thing. If you don't have enough power, the Pis are either going to be really, really slow, which they already are with what I'm doing with them, or they're going to crash. And if you're looking at the console log, if you're actually plugged in, I had when I was originally setting them up, I would plug them into my desktop at home. They would start complaining because they don't have enough power. So make sure your Raspberry Pi, especially if you're doing anything like this, has enough power. So that's the infrastructure. So this is kind of the network. This big box up here, which shows up, the background is green on my monitor, doesn't show up green, but this is the internal network that's on that router that I pointed out. I've got a subsonic server that's running on one Raspberry Pi. The 5 in green, that's actually one Raspberry Pi running Docker, 5 different containers running on one Docker instance on a Pi. And yes, it does work, but it takes like 10 minutes to come up. Very slow, but it does work. I've got a Kafka running on a Raspberry Pi for no other reason than say I'm running something with Kafka. Could have been I'm not using Kafka to its full intent, but Kafka is running on a Pi. That was a little tricky, we'll get into that. And then I've got a random number generator to the right there on the top Pi using software-defined radio, and that's the antenna there. To the left, I've got an Oracle code card. If you went to Code 1 last year, Oracle was giving these things out. I somehow ended up with 2 of them. And while I can do some stuff with them, they're not great. They're pretty wimpy. I also have something in the bottom left called a particle, photon. Particle is, again, I guess I'll get into the details later, but it's a hardware device. If you can't see it, this is kind of what it looks like. Of course, I've got the Minecraft people on top here, but we're all geeks. We like Minecraft. Again, the bottom one, subsonic, Docker, Kafka, random. Excuse me. If you want to hack into my network, the addresses have changed, so they're not what they were there yesterday. So let's talk about subsonic. Where I talked about RadioNonsense and I would stream things using, I guess I didn't mention, I was using Java Media Framework, basically, to play my MP3s. I don't think it's been updated in years. It's crappy. It was unreliable, things like that. So I was kind of rolling my own. This is a great tool if you need to have your own personal music collection managed. It does more than what an iTunes does. It manages things. It will allow you to play things locally. It will allow you to stream things. It's a pretty cool tool. Supposedly, it can handle terabytes of songs. I don't have terabytes of songs. I've only got what I was able to fit on a 16 gig SD, but it seems to handle those well. And again, it can play or stream music, lots of different formats, MP3s, OGGs, FLACs, WAV, Windows Media, lots of stuff that I've never heard of before. It also will rebroadcast or restream internet radio. It will download podcasts. It will stream videos. I've never gotten really into that. And it integrates with some Android and some iOS apps. This is where it gets tricky. Subsonic says they're free, except you need a premium license to integrate with some of these applications. There is a license-free alternative called AirSonic. There's all sorts of politics about at what point does Subsonic require licenses. It's not expensive, but nevertheless, it's there. Installing on a Pi was actually not that difficult. I've got the instructions in my GitHub repo. But the real reason I picked it was it's got a RESTful API for app development. And I created a bunch of RESTful APIs for it. So again, this is the Subsonic running on my application, my bottom Raspberry Pi here. Now, if I look at, so these are all of the Subsonic different systems that they support, all of the different methods you can do to manage your songs, to get songs randomly, to search for things, to run things. The one thing the API doesn't appear to have is anything with controlling how to stream. I can play music locally. I can't seem to do the streaming. So I've got to talk to the author about that, the current owner of it. Come on, where are we? There are 16 services. All the parameters are query parameters, so ampersand this, ampersand that on the URL, get calls. And what I did is I created an XSD that represented the response object and created interfaces for everything, and then I used retrofit to do it. I figured I had to show some code, right? This is a coding exercise. I don't know if I'll get through everything anyway, but it's real easy to... Have people used retrofit? Do you know what retrofit is? So retrofit comes from Square. Square is a vendor in the US where you can plug into the top of your phone a device that allows you to take credit card payments. And so retrofit, basically, the juxta of it is that you define an interface, and then you go and build, using that interface, you say, where do I want to point to? I want to point to some URL, and I want to, in this case, I'm doing JAXB, you can do JSON, whatever you want, and it returns an object that is basically your client-side code, and you have an interface, and you just call methods on it, and you say execute the method, and that's kind of what we're doing over here. I've already gotten the Jukebox interface that has all those methods working for it. I pass in a bunch of parameters that are going to represent all of the question mark this, question mark that URL parameters, and I call execute on it. Now it can throw an IO exception, and we've got to break out of it. But in this case, what I'm doing is I'm saying, give me the playlist, and if it's not empty, I want to go through the playlist, and I want to remove every song one by one. So I haven't had to do any real work on the client side. I basically delegate everything to retrofit using the API. All I had to do was define what that API is, and where's my IntelliJ? So it's something like this. That's the get call, get album list. That's the actual what's in the URL. These are all query parameters. Not all of them are required. User password version client is type as I think the type of the request. Miscellaneous other stuff. So if you haven't looked at retrofit, it's a pretty cool thing. Second Raspberry Pi is running Dockers. Really easy to install. There's a script, you run it, it installs it, you do a few things, so it starts on boot. And again, I've got 5 containers running on this Raspberry Pi. So I've got a scheduler. Scheduler goes out, sees if it's the playlist of what songs are upcoming is under a certain threshold. If it is, it goes out and tries to find songs to add to the playlist so music keeps playing. The Now Playing service basically says, has the song changed since the last time I checked? If it has, obviously a new song is playing. I'm going to publish an event to Kafka for anybody who cares about it. The scheduler will actually publish calls that we've queued up songs. If you dequeue songs, all of those types of things. The Twitter service will pick up the subsonic events from the Kafka queue and publish to Twitter in some crappy text that just says, hey, the song is playing, but at least it does it. The code card is a service that will take the events. I basically have got 2 buttons. There's a short press and a long press on them. The code card service itself has a lot more methods on it than 4, but you can set up whatever you want, and they're all, again, get calls. One is to go to the next song, go to the previous song, clear out the playlist, get some random songs, all of those types of things. And then Particle, how convenient. Particle, you can see the little LED flashing. This is a device that, I've coded what I wanted to do. You saw the little light flashing. It was convenient, it was there. That was Morse code for whatever the next song was playing, because the Particle service will pick up the events and publish them to this. This will also take events and send them back in. We'll get into that, but this is a Particle. This is a Photon. We'll get into some more of that. That's all it's saying is that there's actually 5 services that looked cool, but it's probably unimportant. Only 2 of the services did I expose ports for. The rest of them I didn't really care. They don't have calls that you can make, so I didn't have to publish any ports. I literally just need to have ports for the code card and the Particle. And again, they're different ports. I'm using 8080 for one and 8000 for another. Again, all 5 services do successfully run on this Docker, just slowly. Kafka, publish, subscribe messaging. I'm running it on bare metal. I would have preferred to run it on Docker, but the problem is, number one, it's difficult to find an ARM image of Kafka, because you've got to have ARM Java and things like that. Docker Compose, I found some great Docker Compose scripts to starting up your Zookeeper and your Kafka and everything like that. Docker Compose isn't available on the Raspbian image. And finally found an image, finally got it working, and it was even slower than the one running 5 services. So essentially I put the Kafka back on a single bare metal instance. There's no robustness, there's no reliability, there's nothing that Kafka is known about. This is really kind of a dev-like instance because I'm just running a singleton. But the services can publish events to the Kafka topic, and then you can pick them up and do things with them. And then I have a random number generator. I actually got this idea from a Devox UK presentation 3 or 4 years ago where somebody was using a software-defined radio to pick up radio waves like from Schiphol airline stuff, and it was pretty cool. I'm actually using mine to generate randomness. We know that the random number in Java is only pseudo-random. You give it the same seed, you call the same events, you're going to get the same values every time. This one is, I think, probably about as random as you can get. What we do is we turn to an FM station, and I've got it set up to go to BBC 4, I think. Let's see if it actually is working right now. It was a minute ago. Actually picks up. So it's picking up BBC 4, and it's reading the bytes in from the dongle, and it pipes it to a Linux or a Unix first-in, first-out file. The service itself doesn't actually know where it's getting the bytes from. It's just reading from that same file, puts the data into a circular buffer, and then anytime you need bytes to generate random numbers, it just goes and increments through the circular buffer. And that circular buffer is always getting refreshed, so it's going to be pretty random. The data is going to be based on your current broadcast, right? I mean, and if it's a live broadcast, it's never happened before, so very difficult to retrieve and do again. Not only that, weather conditions or broadcast quality are all going to affect it, because if it's different, if it's a lower feed, earlier when I had this over on the other side of the table, I wasn't receiving very well, that's going to be a different number or a different quality of bytes than when you've got a better, or weather is going to affect it. And if you're concerned about it, you just change the station and something new is happening. Again, I wanted to run this in Docker, but I couldn't. In this case, it runs on bare metal, and that's because first in, first out files are not available within Docker. So I would need to find a different way of getting the bytes from the dongle, from the software-defined radio into. So I've got two IoT devices. I've kind of been talking about them as we've gone along. I've got an Oracle code card, which is really Arduino-based. Do people know what Arduino is? Okay. So this is a simple Arduino card, not very powerful, but it does have Wi-Fi built in. It does have some buttons. It does have a display. And I've set it up to do a left button. Short press will start and stop the jukebox. A long press will mute and unmute. The right button, short press, will go to the next song. A long press will go to the restart song. So a few problems that I've had with this. First off, pressing the buttons here doesn't work. So then what you do is you hook it up to your laptop, you get to the command line, and you issue what would have been long press A, long press B, or short press B, and then it would execute. Okay, that's fine. The second thing is that it's not patient. So it kept saying that the call that I was making failed, when actually it would work, because the Docker service would be a little slower than I was expecting in responding. It would respond slow. This guy would say, oh, it didn't work. Occasionally it would work, but for the most part it would fail. I even had some code to make, to put on here what the next song was playing. It just never really worked. So depending on our time, and we're going faster than I wanted or I thought, we might get into a little bit of that. The other IoT device I have is a particle photon. It's Arduino-based, but it's really not just an Arduino card. It actually comes with a complete platform. So this is the schematic that they give you. It comes with two buttons already predefined, set up and reset. In the middle, you've got this LED. This is what was flashing the Morse code of what the song was that was playing. It has pins, digital pins, which are high and low, just on and off. Analog pins that can take values and be a little more discriminate. I am not an electrical engineer. I do not know what I'm doing. I'm just copying from other things I've seen on Arduinos and things like that, resistors. But there's plenty of stuff out there. Now, if you look at let's talk about this first. Like I said, it's a complete platform. It's an end-to-end solution. They've got cloud-based management. You register it. You can monitor the device. You can do over-the-air firmware upgrades. You can code and dump your sketch on it. Logs, diagnostics, all of that stuff is available in the cloud. The hardware, again, it's Arduino-based. It's got a little bit more memory, a little bit more flash. This one has Wi-Fi built into it. They also sell a version which has cell access. And I think they're selling a third version. I haven't looked into it much, with mesh networks of some sort. So I've got the Wi-Fi that this is connected to is this router here within my network. But because everything is cloud-based, it is actually not talking to any device locally. It's going out to the cloud and back in, which was tricky to do because we've got a little enclosed network and I need to get back into it. Other fun stuff. I don't know if anybody's done Arduino coding. It's basically C, C++-like. They've got a really cool web app for writing your code. They've got APIs specifically for some of the functionality that Photon provides. There's basically 4 ways you can communicate with it. You can actually, on the device, register what will become RESTful calls, and then you make those RESTful calls, goes out to the cloud for Photon says, oh, I know where that is, and sends that RESTful call to you and executes something. You can subscribe to Particle Cloud events. You can send events to the Particle Cloud, pick them up, or the device itself can pick up events, send events, and you can pick them up. And the cloud actually has a way of triggering webhooks so that a web call can be made to your device or your service, and I actually have that calling one of the Dockers. Again, the tricky thing is everything goes through the cloud. So even though I've got this guy hooked up here, there is no local communications. This guy is hooked up. And if I go to, let's see. I should have done this before. Okay, so I don't remember my passwords. Damn it. So everything is in the cloud, and it would have been really convenient to use it. But even on my cell phone, I've got an app that knows of this device. And I've registered two functions. One is for the green. There's a green LED. One's for the red LED. I can make the red flicker, or I can turn on or off. I'll turn off. And my phone is connected to, I'm on the Wi-Fi of the site of us here. So, everything goes through the cloud, which makes kind of the communications a little tricky. And it would be even cooler if I could show you the console, but since I didn't log in. Closer image of what I've got wired up. That's the built-in LED that I've got doing Morse code. I've got a green LED that should flash green when the player is playing. If you stop the player, an event is sent and it turns off the light. The red will flicker when songs are being queued up. We probably haven't been running long enough and there haven't been new songs queued up, but it would flicker at every song that gets queued up. The button has 3: short, medium, long press. Short press will skip to the next song. A medium press will start or stop the jukebox. The long press will mute or unmute the jukebox. And these things are all digital. So these are all the digital pins up here. Down here, it's an analog. I've got a pottometer that will change the volume. And again, anything here that I do goes up into the cloud, back down into my network here. And again, the particle, this is what I'm talking about here. The service sends events into the particle cloud, or RESTful calls in the particle cloud, which gets communicated to particle. Particle generating an event goes back into the cloud and makes a webhook call. Now, because this network is an internal 192.168 type of network, the cloud can't go right into it. There is something called Servio.net, which allows for remote webhook calls. And essentially what happens is you do an SSH-R, forward some ports, and this guy makes a call that forwards it to Servio, and Servio gets it back into me. It's pretty tricky, and I'm not sure how it works successfully as much as it does, but it does work. So we're going to try a demo, and I'm going to cross my fingers that it works, because, of course, once you so it's playing some music of some sort. Now I hope if I do a short press, the song will skip. Crossing my fingers. It worked earlier. And I bet the Servio thing. I'm wondering if the local network went down because I'm not connecting to Servio anymore. Well, that was a failure. So let's go to the code card and okay, maybe that did work. Sometimes takes a while. Okay, so now let's try it again. And I'm hoping it skips songs. Please. Stop the song. Now, okay, we're going to try and skip the song once again. Yay! This was the riskiest of all of it because this is going out into somebody's cloud. I'm not... Now... Well, it partially worked. It did work earlier. I think you're probably right that the volume went down. Who knows what I did? And the green light came on as we started it up again. So it's working. This is very brittle, so this is nothing you would ever do in production. But for a home project, it works well. The other device we can look at real quick is the code card. And so basically to do that, you have a terminal emulator, which is screen, dev, tty, USB. So again, this is all the Arduino stuff, and it's got various commands, short press A, short press B. If I do I think it's an ls, it will show me what I've got these configured as. Maybe. So you can see up there that says button 1 is HTTP Docker .jukebox.lan, which is the local network, port 80, code card, next. So the short press would go to the next. The problem with this thing is it's just an underpowered card, and it doesn't really want to work. But it's basically doing this. Docker.jukebox.lan, 8080, code card. And you can see how slowly this responds, and that's all about the Docker services having 5 running on one Docker on a Raspberry Pi. Hence, well, it was working at one point. Failed to connect. Well, this is where everything goes south, right? We had it working. So a partially successful demo. But basically, you know, this is something just kind of for fun. I might actually use it. I might actually put it up in my house and you know, connect to it at work. There's future enhancements I'd like to do on it. Java 11, Java 12. I'm stuck at Java 8 because I haven't really had a chance to dive into it at work, so I didn't want to risk timings and things like that. So I should upgrade this and use modern technologies there. Thinking about doing a private blockchain, maybe an Ethereum or something like that. In the US, copyright law, they end up licensing, what songs get played. And radio stations, because I used to work in radio, have to track occasionally what songs are getting played so that they can calculate what the right licenses, what fees are being paid to the artist. Well, what better way than to keep all that information in blockchains, which would be immutable, and you could just keep pushing, like this is song was played next, this was song was played next. I would like to work with Subsonic guys and figure out what are the calls to actually control the streaming. Right now, again, all I can do is the Jukebox, which is when it's plugged directly into here. I would actually prefer to be able to make a web player. If you look at the Subsonic, there's ways, and we could go into it if we wanted to stream to either a device, to a web page. You could use something like a Winamp or an XMMS, something and stream directly to my work laptop, my work desktop. I need better logging. Basically my logging is all stuck in system.out print lines, which is great for simplicity, but doesn't help if I actually need to know what's happening. I'm sick of doing Docker logs commands that have it dump out long lists of things. And then what I didn't say is, there's things I could do here that would be cooler. If you had a light sensor of some sort and use that light sensor to turn up or down the volume, perhaps, if you wanted to do that. There's all sorts of electronic devices which I know nothing about and don't know how I would use, but I'll find them. And again, this is a pretty easy device to work with. You probably could do a complete session on particle infrastructure because it's actually pretty cool. And we didn't get into the details about how the events are published, the fact that there's a Java API which I'm using to access the events or to send events. It's pretty cool stuff. Any questions? I went through that very fast thinking I was going to run out of time. We got about 8 minutes. Any questions? And I better put on my glasses because I won't be able to see you otherwise.
Is your radio station still active?
No. I don't remember when I killed it. Part of it was my internal infrastructure at home changed. I used to have a static IP address. I don't anymore. I used to host all my own email services. For 20 years, I hosted my own email. Why any sane person would do it, I don't know. So I haven't for a while. I might bring it back to life using some of the stuff I've done here. Subsonic by itself, you expose port 4040 and suddenly you can get at it from work. But that's not as much fun as doing unnecessary complexity like this. Yeah?
I'm curious, you said that the bottleneck are the pies right now, or are the devices that you use to control the pies, like the small card?
The Pi is kind of the bottleneck, this one in particular, because it's running a Docker with 5 services, 5 containers, and it takes about 10 minutes to get to the point where music is actually playing. Each service gets their little time slice to start up, and it slowly makes it there. It works, which is great, because literally this is all set up, so all I do is plug it in, everything boots up, everything starts automatically, but if you go in and do Docker logs on it, it's painstakingly slow. Probably I should not have that many. I think 3 ran okay, but then when I got the 4th and the 5th, it really started slowing down. Because it's 5 Java, fairly large Javas, and I'm sure they're doing a lot of thrashing. And as you saw when I tried to make the code card call, it seemed to time out, which probably because the Docker instance got put on disk on cache somewhere just because it wasn't being used.
And one more question, if I may.
Yeah.
Those Dockers, what they run, what server they run on?
And I'm supposed to repeat the question when I'm up here, and I'm not doing it, so I apologize. The question was what OS is running on the Docker?
Not what OS, I assume it's Raspberry inside the Docker. Yeah, what Java server do you run?
This one, and I think I had it on a previous page, the Docker image that I'm running is Hypriot RPI-Java. It was really tough to find. Yeah, that was one of the things I skipped. So first off, you had to find an ARM-based distribution image to use. One of the problems I had with it was it didn't have any key stores. It didn't have any security certificates. And so I would make calls to Particle or I'd make calls to Twitter, and they would say, go away, I don't understand you. One of the things I didn't do, let's see. I had the link in here somewhere of the Twitter feed. But anyway, so when I made the Twitter calls, it would complain. The client would say, I don't understand these certificates. So what I ended up having to do was copy a key store from someplace else onto the Docker, onto the Pi, and then mount a volume pointing at that to make it think that it was local because of that. Yeah. Cool.
Have you considered using SDR to actually broadcast?
Have I considered using SDR to actually broadcast? No. I don't even know if that's possible or legal. Probably it's under power limits, but no, I have not looked at that. I was really intrigued by the presentation a few years ago where the guy was picking up airline stuff from Schiphol and using that to map it out on a Google Maps, the flights going in and out. But I haven't looked at broadcasting yet. Any other questions? That's it. Thanks a lot. I appreciate your time. I hope this was enjoyable. Oh, and I should, in case anybody wants to take a picture. There's my various contact information. The GitHub, there's a repo called Digital Jukebox, or Jukebox, I think, in case you wanted to look at the code and grab it. It's all in one single IntelliJ project. The slides can be found on my SlideShare. And there's a Twitter, which I don't use that often, but feel free to look at the code. Feel free to send me questions if you've got, like, what the heck were you doing here? And I'll do what I can. So thanks a lot.